Hi, I'm Chad Babcock, and I'm a professor in the Forest Resources Department at the University of Minnesota. What we are looking at in the above map is above-ground biomass for Cloquet Forestry Center, which is a University of Minnesota-owned research forest in northern Minnesota. This map was produced using field plot biomass observations and Minnesota's statewide LiDAR collection. The map on the bottom is a map of above-ground biomass using field observations alone, so no LiDAR in this one. Notice that is basically an interpolated surface where we see high and low points at plot locations and a smooth decay to the overall mean biomass as we move away from plots. You can use this little button here to turn on the plot locations, and you can see where one plot will have higher biomass around it. If we click on here, it should show up. Yep. So we see biomass is about 125 megagrams per hectare here, and then we see the slow decay over to places where there might be lower biomass. So here biomass is quite a bit lower. So we see this smooth kind of interpolated surface between all these plot locations. Where in the LiDAR informed model, we still have the plot data in there, but we have a lot more differentiation between plot locations because that LiDAR data is giving us all that height information to help us out. So both of these maps were made using a Bayesian hierarchical spatial model, which allows us great flexibility concerning how we summarize and present uncertainty, and still remain statistically rigorous. So this means that when we generate a 95% confidence interval, we can safely interpret that and say, based on the information that we've included in the model, we are 95% sure that biomass in the area falls somewhere within that interval. So one key feature for carbon markets is that we can calculate mean and total biomass for any area of interest within this domain. This web map lets us play around with this. Keep in mind that even though we are just looking at a LiDAR-based map in this example, this method can be used with any biomass or carbon map that may be out there and potentially useful for helping us do carbon accounting. So first we can draw a box around the entire Cloquet Forestry Center, like this, and then our web tool here is going to calculate how much biomass is in Cloquet. It takes a second, but not too long. So here we're looking at a posterior distribution of above ground biomass density in Cloquet, and we can see that it's around 21.5 megagrams per hectare with a 95% confidence interval ranging from 20.5 to 22.3. So the confidence interval width here is about 1.8 megagrams per hectare. So we can calculate biomass for the map that only includes the field data, and then we get the same sort of output over here, but we can see that our estimate here is around 24 megagrams per hectare with a 95% confidence interval between 22 and about 25.5. So the confidence interval width here is about 3.5 megagrams per hectare. From this, we can see that the LiDAR data is clearly helping us estimate biomass compared to relying on just the field data alone. We can also do small area estimation with Bayesian hierarchical spatial model output. This web tool lets us draw arbitrarily shaped polygons and then calculate biomass for how much is inside these polygons. So inside this polygon, we estimate around 54 megagrams per hectare with a range between 41 and 70. So notice that that confidence interval range gets a lot wider because we're getting into a lot smaller area. And if we go even smaller, so like if we grab just a couple pixels here, we can see that that range gets even larger. So this is a fairly sensible result, though. It should be easier to estimate biomass density for large forest tracts rather than for areas that contain only a few pixels. I haven't built it into this web tool yet, but this modeling approach allows us to generate means and totals for areas that are not connected as well. So you could imagine drawing 2 or more polygons on the map and getting an estimate of the total across all of them. So in short, we think this is a really cool modeling approach that, if executed in the right way, can be greatly beneficial for assessing the use of different remote sensing products for forest carbon monitoring.